Hi, my name is Starzynska. I am a PhD candidate at the Royal College of Art. The title of my paper is Machine Vision and Algorithmic Creativity. In this paper, I'm going to discuss examples of selected machine vision projects, as well as research project in which I have applied machine learning to architectural style recognition. The main focus of this presentation is the relationship between data and the learning process of the emerging system of non-optical visual perception. Italian architect Filippo Brunelleschi developed mathematical perspective in the early Renaissance. Adopted by fine art in the West, this visual paradigm was later spread by photography and film, becoming the dominant form of representation in the Eurocentric visual culture. Perspective showed the subject as if watched by a single, motionless eye, an eye stripped of its body. Today, the rise of a new cognitive system is challenging this centuries-long construct. Media theorist and data philosopher Matteo Pasquinelli proclaims that machine learning emerged as a response to overproduction of data. Quote, "The regime of visibility collapses to the regime of rationality. Algorithmic vision is not optical." End quote. Attention is replaced by a selective filter vision by pattern recognition and anomaly detection. Machine vision is no longer optical, and perception is no longer an anthropocentric domain. Machine learning models have first been proposed in the 50s, but for many years they have been left behind in favor of hard-coded systems. Their recent advent has been prompted by three major factors: big data, parallel processing, and advanced algorithms. Machine learning is a process where an algorithm solves problems by learning about them from multiple examples. Based on a statistical understanding of those examples, the system proposes original solutions. In my research, I'm focusing on the supervised learning, which is a method of training a system to recognize members of different categories by feeding it multiple examples of a previously labeled dataset in its training state. I am particularly interested in networks called convolutional neural networks, also referred to as CNNs. The network's architecture consists of multiple hidden layers, each of which is learning about different features in the training state. The input data is abstracted into a pure mathematical form. Those abstractions begin to exhibit patterns, and the patterns form the basis of the network's comprehension of the subject. Every system learns about features in their own unprecedented way. This process is referred to as deep learning. While contemporary networks can perform image recognition surpassing human accuracy, the exact details of what the network has been recognizing has not been easy to visualize. In an effort to understand this process, in July 2015, after a year of research, Google AI division DeepMind have decided to run a CNN in reverse, creating a project called Deep Dream. In a standard deep learning process, so-called weights of the network are being adjusted to achieve more accurate image recognition results. In the Deep Dream experiment, the weights remained unchanged while the image was being adjusted. Increasing feedback loops led to the network creating extraordinarily abstract and uncanny visuals. On the screen, we can see an image of the sky enhanced by a network trained to recognize animals. Here, results of a random image enhanced by the network trained to recognize buildings, pagodas, or birds. And finally, a system that have generated an image out of white noise. In this strange case of pareidolia, it searched for what it knew. In this case, landscapes populated with Oriental architecture. Here, the seemingly objective reality is translated into its mutated form. The algorithmic abstraction of data dismantles the familiar reality into an unrecognizable noise. Pasquinelli claims that the algorithmic process reaches beyond our limits of perception. What is restored is a stylization of mathematical model presented in a pictorial form. A German artist, Clingerman, uses generative adversarial networks, referred to as GANs, to produce impressions of paintings. In his practice, he trains GANs on thousands of images of paintings, generating novel artwork, such as the one we can see on the screen. When talking about his practice, Clingerman notes that the algorithm has the tendency to bring out the uncanny. Reflecting on his work, he notes that we, as humans, are visually trained on the world we see around us, and any deviation from it can make us feel uncomfortable. The strangeness of his work illustrates that there are differences between how the algorithm perceives the image to a human agent. The same medium can be perceived in different ways depending on the cognitive system examining the subject. In October 2018, auction house Christie's was the first ever to sell a work of art created by an AI. Portrait of Edmund de Bellamy was created by a group called Obvious using GAN. The image sold for $330,000 while it was originally valued at only $10,000. The sale organizer, Richard Lloyd, commented, quote, "It might not have been painted by a man in a powdered wig, but it is exactly the kind of artwork we have been selling for the past 250 years, end quote. The comment raises a question of creative labor in machine-generated work. Mario Clingerman, as well as another artist working with machine learning, Anna Riddler, both are of an opinion that the machine or the code that was designed to produce the image in itself are a creative product. This assumes that the creativity must be linked to labor, which is a position challenged by a sociologist and a philosopher, Maurizio Lazzarotto. In his essay Art and Work, he regards creativity as constantly being in its nascent state, that is the opposite to the act of work. It can be argued that the aesthetics of an algorithmic work is not a simply interpretation of a training set, but could rather be analyzed through a prism of a metaphor, as described by a 20th century philosopher, José Ortega y Gasset. Graham Harman notes that metaphor is a non-linear form of cognition. As Ortega puts it, a metaphor is not a trait of likeness but, quote, satisfies us precisely because in it we find a coincidence between two things deeper and more decisive than any similarities, end quote. For Ortega, by bringing new meaning of a known object, the metaphor makes the visual experience much deeper. The way that the algorithm interprets the dataset then builds new relationships between its members and finally makes the generative image functions as a metaphor for the dataset. This type of work assimilates and expresses qualities of all of the training set images in a way that are strange to human observer. In my practice, I deployed machine learning as a process of unlearning in architectural history in order to gain an alternative understanding of visual representation of space. The aim of my project was to train a neural network to differentiate between 4 architectural styles: Gothic, Renaissance, Baroque, and Modernism, and then to examine what are the different patterns identified by the network in each of the 4 classes. I have begun my project by assembling a training set, looking for sources of pre-labeled data. I have gathered images labeled by Pinterest users, as well as images from RIBA pics collection under the same keywords. This was acquired through a process referred to as web scraping. It quickly became apparent that RIBA pics is a highly curated dataset, while user-generated Pinterest collection includes images that have been subjectively related with the keyword. I have focused on the user-generated dataset as more representative of the current condition of uncontrolled overproduction of data. Images have been selected at random in order of appearance and have not been curated, as the aim of this exercise was to account for any randomized set of information. I have begun my work with neural networks by testing a pre-trained algorithm called AlexNet. I have fed it a single image from a Baroque architecture set. The network returned the answer as Vault. Baroque was not in any of the training set examples, so the network had no chance of identifying an unknown category. After the process of image recognition has been completed, I have begun unpicking the network's structure to try to understand what the network was seeing. If each layer of the network has learned to understand a different feature of an image rather than a final product, I was intrigued to visualize those individual abstractions. Layer by layer, I reviewed the subcomponents that make up a visual vocabulary of this intelligent agent. I used a process of visualizing channel activations, which is usually applied to detect whether the layer is recognizing correct features. This is expressed in the form of grayscale image, where black and white areas indicate positive or negative activations. Created maps of shallow layers are usually associated with high-level patterns such as color scales or edges, which are easy to identify. However, the deeper the layer, the more abstract the activations, with some that become impossible to decipher under visual examination. Moving on to my generative work, I have retrained AlexNet to distinguish between my 4 architectural styles. Each of the 4 sets contained 750 images per class. Once training was completed and tested at 64% accuracy, I used Deep Dream method to generate images that illustrate the network's interpretation of each of the styles. On the screen, we can see the results for each of the 4 classes. The study has shown that the images of buildings, when abstracted, are remote from the visual content of the training set. However, each set has produced a distinct aesthetic that encompasses geometric regularities of images rather than buildings. Immediately, we can see that none of the images show a specific building. Image corresponding to the Gothic architecture training set shows a composition of elongated expressions followed by busy areas, clearly resembling geometries of rose window patterns. In all of the examples, the neural network has treated the geometry of a building and the perspectival representation of space as 2-dimensional shape. The depthless composition of patterns is not an abstraction of space, but rather an abstraction of medium of photography. Synthetic vision is very different from an optical experience. There is a profound relationship between the process of learning and making, a distinct workflow that the user needs to be mindful of. Each step preceding the generative act has a significance in its contribution to the final image. It is, however, important to differentiate between the role of the algorithm and the role of the training set. The control over deep dream code, such as number of epochs or dream iterations, is how the network is learning. However, the data set determines what is being learned. In my project, Deep Dream was used as a framework that facilitates a process of translation. It is a method for visualizing a statistical, non-optical experience of the artificial gaze. Thank you.